Let's get it. Next day. Today I want to do 6 sessions, or four sessions. So 4 2 hours. So hour and a half of study, half an hour off, etc. Keep going. During one of the 30 minutes, it'll probably cut into time a little bit because I need to cook lunch for tomorrow. Because I have lunch for today, dinner for tonight, but I need lunch for tomorrow for work. So I gotta cook at some point. So we'll do 3. I almost want to do 2 tests, but it's probably better just to get more information in the brain and keep on accessing. Oh my! Alright, well that's the start time. Say till 11:30. Okay, hour and 27-ish. Alright. Oh, fuck. Okay. What? Failed? What? Wait, what? What did I bookmark that says? Oh, result 2 failed. Result 2 failed. Okay. How many results? Okay, it's only these. Alright, cool. So, the failure here, that was because we were using standard optional, which... How do we describe it? It's not a Boolean, it's a... Hold on. It's that when I evaluate it as a condition, I guess we don't even need an operator. It evaluates it dot value. Isn't that what it is? Or dot value, or isn't it something else too? It's like a member function or something else. Let me see what's going on there. Come on, bro. Oh, wait. Wait, that's actually the strat. I think tab is the way to to complete the IntelliSense thing. Just have to hope it's correct. Well, oh yeah, I need standard optional. Sure. Alright. But then we say that. Oh, dot has value. That's what it is. So has value. Can I print this as a bool? Oh shit. It is a bool. Huh? Fake is an optional but has value. Is a member function, seems like. Because it's part of the standard optional class. But it's a template class. I think that's what this is. That's why I'm going to get into that in the next chapter, 13. Template classes. Where I have a class. It seems like it's more advanced than a class, to be honest. But so it's a member function of the optional class that has a template, but not... It's not a non-type template parameter. It's specifying the type of return value. And it's const expression, so it'll try to evaluate at compile time if possible. And it receives compile time values. And it returns a bool. So in this case, 0. But I could still initialize it with 1. Or whatever. Any huge, whatever. Any integer. So doing the same thing here, like this, I guess, is like, if we do if thing, it seems like that's the same as thing dot has value. Like that. And then dereferencing it is the same as thing dot value. Like that. So, and this should be an end line because there's one extra 1 there. Oops. Cool. All right, so that's standard optional. So we could use it to check stuff. When would I want to use standard optional? When there's risk of not when there's risk of the function failing to do its main objective, which would be like sort this array. But if there's like an invalid value in the array, then it fails. Or maybe what? Can we do optional void? So it normally does nothing. Or like we want it to do nothing, but we could still return a success. But it would need to be a function because I don't think I can make an optional value. Standard optional void? Wait. Line 5 is the issue. Oh, I think it's having... It doesn't know that this is the function yet. It's thinking that this is a standard optional void int main, I think. Because if I bring these back... Yeah, the errors don't change. That's what it's thinking because it doesn't care about white space. Whatever. Find target. Uh-oh. Uh-oh. Hold. A reference to? Whoa. Okay, void is not cool. But int can be cool. Damn. Alright, never mind. Because I was hoping I could have one that's like, it would be my, well, I guess I would have to just assert that something was true or that something happened. So if this function was like, attack, and that's it, attack, a player can attack or an enemy can attack, and we pass in whoever the attacker is and whoever the attacked is. So the attacking character and the attacked character. And then somewhere in there, there's a check to see if the damage is valid or if the health isn't equal to what it was or something like that. There's a check to make sure it's successful. And if it wasn't, then we return the null option to show, hey, this doesn't have value. But if it did have value, then it would be void value. So it makes sense that we probably can't do that. So we would have to do like, I mean, I could calculate the damage, and then if the damage is 0, then we could return null opt, and hey, the damage didn't work, and if it's not true, then there's no damage to apply, something like that, instead of just applying 0 damage. Because maybe we don't want to apply 0 damage ever or something like that. I think it probably depends. Okay. Another allergy day. I get a new mouse pad tomorrow so I can see if my mouse starts working better. Alright. Oh shit, here we go. Yeah, a class template type. Yeah, I didn't. Oh shit, yeah, there is all this other stuff. I just only had time to get to here. And then had to kind of proceed with my intuition. And the self-test we did after. Okay, so in this case, this is a function that should return an int. Or that, I guess we say that optionally returns an int, so it can return an int or null option. And if the return value is true, then it has the value. And if it's not, then it doesn't. And if I try and get the value of it, it's kind of like a null pointer. Like, I'm pretty sure I can't use it, right? Oops, not standard null. Excuse me. Can I do that? Initialize it with that? Oh shit, that looks interesting. Does it say anything about this? No. Okay, it's happy with that. All right. Now, what if we say I might not need that here? What if we say thing? Or what if we say dereference thing? Uh-oh. Or thing.value. Can't discard stuff. Okay. Because it has to be used as a condition and we can't. Okay. Alright, so what if I try and output it? It's not being discarded now, it's being used. But, oh shit, it actually does say. Excuse me. Now what if we said value? Uh-oh. Oh wait, it's not, it's called thing, whoops. Okay, so we can't output it as is. We can check it, or we can use the value. And we could do standard bool alpha and extract thing.has value. Oops. Has value. True. Oh shit. Oh, what if we just did that? False, no value. Oh. What if I initialized it with a standard optional int returning guy called do thing, and it returns that. Null optional. Oops, it returns that. And we call this. Interesting. So it doesn't have value here, even though it's initialized with null opt. But if I actually give it a null opt initializer, then it does have a value. All right, some of this is interesting. I guess you don't want to do that then. So I can have a value of type t or no value at all. And we can check to see if it has the value. And if it has a value, then we can see what the value is. And I can access it by doing that dereference thing. Or, so like, thing like this. In this case, it's 0. In this case, oh. So if it doesn't have a value, then that won't work. Is it the same thing if I do this? Yes. Okay. So there's a difference between initializing it with a return value of something that returns this, and initializing it with literally whatever the closed braces are. I'm gonna have to go to the bathroom again in a second. Holy cow. Alright, so we have this result. That's a type of standard optional that should be getting an int. If that has an int value or it doesn't. Pass in 20 and 5. Excuse me, we're doing division, so we should get 4. In this case, y is not 0. We're not dividing by 0, so we return 20 over 5, get 4. Cool. But, and what we're doing here is we're checking the condition of result 1. So we are evaluating it, and when we do that, it's actually evaluating result.has_value, parentheses. It's the member function that returns a boolean of whether it has a value or not. And I guess it just compares its value to null opt. And if it is null opt, then it returns false. Otherwise, it returns true. Then if we pass 5 and 0, it returns null opt to initialize this guy. Or, well, yeah, to initialize this guy. Doesn't have a value. Therefore, result 2 is going to fail. Result 2 dot has value. It's false. So we run failed. So it's 4 and failed. Bop, bop. Okay. Keep it with a value or not. Oh, we can also initialize it with null opt. So either way. Just don't initialize it with this. Apparently. We initialize it like this with nothing, but not with this inside of the brackets or braces. We can choose has value, or if that, it's probably easier. Gotcha, because it already has a conversion. We can dereference it. We can do dot value or dot value or. Oh. Dot value. Yeah, but the problem here is, doesn't this give us the same problem earlier where we don't know if 42 actually is the value or not? So if I call this dot value, maybe the value is 42. But if I call value or and the value really is 42, is this the or 42 or is this 42? And it actually does dereference it. Okay. So it seems like it's a pointer to the actual value. It's like it's a reference to a temporary or something. I gotta go back to me. Be back. Okay, 2 minutes for diarrhea is not too bad, huh? That's what happens when I eat all this fucking popcorn and salt and vinegar chips at the house I'm watching dogs at. Come on. Alright. Yeah, it seems like it. So I'm not sure how that works. Does it mean that the value is... I mean, it's the value... I think when we evaluate it, we can't actually even evaluate it. What was the error that we get? I think it just says that it's not a proper operand. Excuse me. Oops. Oops. Sure, we could do this, or we could do standard null opt. And then, hello? Oh, forgot. Don't have IOStream yet. Yep. There's no way to bring a standard optional there. But we could do this and dereference it. However, bump. I get an issue because it's empty. So how is that even done? Let's see if I can read this, huh? This is how null opt is. Oh, it's here? Bro. So many, 1,000 lines of code for optional. In this case, STL verify this has value. It does not have value. Oh, okay, so it's just, this is all the same shit except this is a const reference. This is not, this is this and no except, a const ref no except. I don't know what that shit is. A type, a reference to a type. That's that little bit right there that we put in angled brackets. Oh shit, I can fuck around with it. Interesting. But is this a reference? I don't know what this is. It's on its own. Operator multiply this. So we use this. It's not dereferencing necessarily. Maybe. Maybe it is. Okay. Interesting. Please go away. Okay. Oh, undefined behavior versus dot value. I think that's the same thing actually right here. Let's just bring this back. Oh, it is different. Okay. Versus it being undefined behavior. And this should be the dereference. Undefined? I mean, it seems like it's defined, but maybe not, I guess. Okay. So maybe value's better, but maybe not. Or just check it first before using it. Seems like we don't want either of these, so we may as well check it and then just not access it otherwise. To hold no value, we do null pointer or oh, hold on. Really? Oh, wait, hold on. Okay, for a pointer versus standard optional. Gotcha. Or null pointer. That or standard null opt. We can give it a value or we can give it an address. So it's either it has an address or it doesn't have an address, i.e., it's pointing to null pointer. Or it's pointing to, it has null opt. We can check if it has value by converting it to a bool, or running has value in this case, either way. Or dereference it, or do dot value. But really the meanings are different. It's reference semantics, meaning it references some other object. So assignment doesn't actually touch the object, it just touches the pointer. Unless we're talking about actually fucking with the value at the address. But in this case, we're saying we're assigning value from a pointer, not from the object. pointer is copied back, not the object. Yeah, it makes sense, because if it's local and we return it, then yeah, we get a dangling pointer because the local object. We can't return a non-static. That's what that should say. It's value semantics instead of reference, meaning it's actually itself. And assignment copies the value. Mm-hmm. Yep. It seems like it's probably not one of those expensive ones then, because we use references to pass standard strings because they're expensive to copy, but not optional because maybe it's just a minimal thing. Like it's the value it has plus just a little bit more as a class object, versus standard string is, I guess, just inherently expensive because of the values it holds. But I don't know, those are just separate characters, so I wouldn't think so, but I don't know. Instead of an int, it just has a standard optional with no value versus a standard optional with the value. So if we return 3, we're returning a standard optional with the value 3. Make sense? Yep. So we'll to check it. And if it does, then we dereference it. Otherwise, we don't want to fuck around. No undefined behavior, please. Or exception, please. Let me dry this towel out real quick. Just need to move it. It's damp from the water yesterday. My eye's good though. The thing disappeared. Cool. Pros and cons, huh? Yeah. Yeah, it's cool because we have a check condition. So we could say, like we could have a standard optional, standard string reference for a game with a rocket launcher, one of the ground to air weaponry to attack planes and shit in the air. And as you're looking in the game, it's checking each of the objects to see if it's a valid target. We'll just say each of the objects is a standard string, and it's looking at them. So you pass it all the valid targets. Maybe you have an array, and the array is called targets in sky, or planes in sky, or something like that. And then you check each one to see if it's a valid target. So we say, hey, is this and maybe each one of this is really an object, and each plane has either a property that we're comparing to see if it's a valid target, or it has a separate property that means that it's a valid target for that weapon. But maybe that's more expensive. I'm not sure. But long story short, we're checking each of those to see if it's valid. And if we don't find any valid targets, instead of returning the valid target, we return a standard optional with no value. Otherwise, we return the standard optional with the value of the target. That way we can say, hey, plane number 4, that's the ID of the plane, that's the standard string value. Plane number 4 returned as the thing, and then, oh, okay. We shoot the rocket, and make it go to the plane and apply damage after the fact on impact to that plane, to that object. Versus having nothing. Then there's no damage, there's nothing. We can check, hey, if find valid target, or if launcher find valid target, or something like that. Or if launcher dot get valid target, so we can have it be a member function, which adds clarity. Because instead of it being like find valid target for what? What are you talking about? But if we have an object and we say it has a member function for find valid target, then we're cooking. So we look and oh shit, no valid target. We looked at plane 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, helicopter 2, 3, 4, 5, 6. No valid target. Return null opt. And then we have logic that evaluates that function return and says if this, then fire the rocket and apply damage to whatever we have as the valid target. Otherwise, display error and play error sound, no valid target, or whatever the hell. They're like the red thing. You're looking and you see, and it would come up with like a little UI saying no valid targets as you're looking around. And then when it finds one, boom. Something like that. Or maybe that's what happens. Like you're looking, and I guess you just have this going on tick, so it's checking all the valid targets every period or something like that. Okay, yeah, this could be really cool. Documents that may or may not return a value. You don't have to remember which value is being returned as a sentinel. Yeah, because it either failed or it didn't. So whatever value we get back is the value. If it didn't have a value, it didn't have a value. We don't need some sentinel error value to return. I don't have to do, oh, try to get input, return input, and if it's invalid, then return a null opt. Then there's no input. I can do that instead of having to be like, oh, well, the mystical 7-star whatever is the invalid character sentinel value. I mean, yeah, it seems like it's pretty damn easy. And then, so what we could say, if that is that, turn that, or... Yeah, let's make something like that, huh? Seems like that'd be kind of fun. So let's get optional, because we know we need it. Okay. Really what I should have done is just made the function first, because the program can't exist without main. We also need option. Well, first we need string, because we need standard string. Let's have... So even with a template still, we're only replacing the type names. We're not replacing the arguments. So I would still need to make another template for a different amount of parameters, right? I could give them default values, maybe, so that we were always calling one with a bunch of parameters, but maybe. Okay. And so we have, let's just say standard string. Target 1. Plane. Excuse me. Fuck. We don't want these to be changeable. Const standard string. Target 2. Or actually, let's say... Yeah, sure, fine. We'll just name them like that. It's okay, I think. Bro. Why is it not? Okay. const standard string target 2, helicopter, and then const standard string target 3. Fuck it, tank. Cool. Okay, and we'll say we need optional, include optional, because we need standard optional T. And we have, I mean, I may as well make it const expression just in case, but there's not really a point because standard strings can't execute at compile time. But maybe we convert something. Let's just try. Const expression, standard optional, standard string, find target, and it takes, here's the thing, because I would need to call the version that has the right amount of parameters, but if I make a template, it won't make separate versions. I would need to manually, I think, make one that takes no arguments, or this many. But I could just make them default. So let's just say standard string target 1. And by default, it is blank. Standard string target 2 by default. And should we say fuck it, equals blank. And standard string target 3 is blank. And fuck it, let's do one more. Standard string target 4 equals blank. Okay. Let's do this. That way it's more readable. Cool. All right, and we will say if and it would need to compare it to a valid target. So let's say in this case, so these are all default arguments, and the leftmost one is actually, let's say this is, there's 1, 2, 3. We're going to get a duplicate name issue, but we'll say valid target name. Okay? And it is not default. We need to specify it. So we're going to call this and say, hey, here's a valid target. We have some number of targets. Fuck it, we'll do another. Standard string target 4 is this. Here are the targets. Return the one that's valid. And hope that, I guess, if it's the only one that's valid, well, let's just say it can only do that. It'll find the first valid target. That's the difficult thing. We don't have the pickiness that we could have if we were like sniping an enemy commander or something like that in a game, and there's like the commander guy, his little foot soldiers are valid targets, but we're looking for the guy. In this case, we would put it up into the air and it's a valid target, and bam, it returns it. But I guess in this case, it's really just finding valid target. So it's saying, hey, this is a valid target, and maybe we pass these in order of proximity to the cursor. So it's looking at the closest ones. So it's looking at target 1 for this range, target 2 for within this range, and target 3 for this range. And so it checks target 1 first and returns that one first. So if there are 2 targets and I put it closer to this one, it's within range of both, but it's going to return this one first because it's within the closer range, which happens before it checks the wider ranges, which then the second target is included. So it'll say no target, valid target, but we're not shooting it, valid target, and if I move it closer to another, it's going to return that one. So if I'm looking at this one or closer to this one, it returns this one over and over again. If I'm looking at this one, it's returning this one over and over again. If it's in the middle, maybe neither, or maybe whichever one is literally closer. I don't know what would happen if they're both equally spaced out. I'm not sure. Well, I mean, I guess it would just return The order would matter. I mean, it would have to pass them in some sort of order. They can't pass at the same time, I don't think. So, okay. So we're going to say if target 1 is valid target name, then return target 1. And this is not assignment, this should be equivalency. Else if target 2 is valid target name. And in this case, we can't take the valid target name as a switch and say, hey, on target 1, on target 2, on target 3, or 4 cases, do this, because switch cases have to be integral values. These are standard strings, they're not integral values. And again, I've done assignment instead of equivalency. Okay, return target 2. Else if target 3 is valid target, valid target name, return target 3. Else if target 4 is valid target name, return target 4, and else return null opt. We could do standard null opt. We could do this guy. Either way, I'll do standard null opt in this case just for variety. Cool. That way I can call it with any argument that I want, and it doesn't have to be, yeah, it's one definition. And maybe this is expensive though, because I'm technically assigning value to standard strings, even though it's tiny value. This is probably still expensive, so it probably makes sense to really, I can't even do a template. I have to do explicit overloads, I think, to have one with this many, or this many, or this many, and they have the same logic. I think that's how that works. So I then I'll have a standard string this target and initialize it to be the return value of find target, passing it tank, target 1, and target 2. What is happening here? What if I passed it target 2 again? Okay, cool. It's still not happy. I'm good. That's good. Oh, and by the way, these need to be references. So how would this work? This would be a reference to... Maybe these can be const? I guess so, huh? That's probably what I would want to do. Make them all const. Oh, and the problem here is this isn't a standard string. It doesn't have a version that's taking that. Okay, so we'll just say a const standard string, and let's say, yeah, sure, a const standard string valid target is tank, sure, and we'll pass it valid target. What in the fuck is happening here? What is it doing? Oops. Okay, hold. Why is it still doing... Okay, thank God. That was annoying. All of these, though, have default arguments. Line 26. Initializing it with... Oh, the problem is that this needs to be... I can't convert a standard optional standard string like this. This actually needs to be a standard optional that or a standard string. Boom. And these need to be a const L value reference, and it's converting... Should these be string views? They probably should be, just because they can be default. So they're either cheaply converting that, or it's then going to be looking at the reference to this and then creating a standard string out of it if this is a standard string. So maybe this should be a string view. I'll do some of them like this, but I don't think it makes too much difference. If we say instead this is a standard string view, hold. Oh, and it needs a name, target 4. Hold. Oh. Oh, true, because I can't return... I could return a standard string view, or I could return a reference to a standard string, but then we're converting a standard string to a standard string reference. So, fuck, I think these all might need to be the same. I mean, let's just see what we have. If we just do a const standard string reference, okay, and then reference, the problem is it can't convert, well, there's no standard string view here anymore. These are const standard string references, 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 and we'll make them const standard string references. Hold a pointer to a reference. Oh no, because it's returning a pointer, so maybe we can't return a reference actually. So I guess we've gone through all the things. We need it to just be a standard string view. Boom, 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 boom. Not a reference to a standard string view. And boom. Huh? Oh. And this is this or that? So I guess would we want it to be a view? I mean, maybe we would want this to be a string view actually, because then we're just looking at it instead of copying the value. Maybe. Okay. And then we could say if this target, we need IOStream. Then output valid target found this target. Else standard character output no found valid target, or valid target not found. Cool. So in this case, we passed in target 1, target 2, and that's it, invalid target. So we're looking for tank. Neither of these are tank, and these aren't tanks either. So these are not references anymore, because I think an optional actually does involve a pointer. Didn't it say you can't have a pointer to a reference? I'm pretty sure you can, because we had a pointer to a const L value reference. But I guess a standard optional can't be a pointer to a reference, maybe? What was it bitching about there, huh? So what if we did this? Make it a reference. You cannot create a pointer to a reference. Okay, buddy. I mean, what if I just did the test? A const L, not fucking const L value, a const int reference. Okay. This is an L value reference called X, but it's to a temporary value of 5. Okay, no issues so far, huh? Okay. Now listen here. What if we have, okay, a um a const int pointer, or hold on, a constant reference, but it's a pointer to it, xp, and it's initialized with the address of x. Uh-oh. Wait, can we not? Hold. I totally thought we could. Didn't we before? Hold. I guess not. Oh, well, because it doesn't exist? Oh, wait. I swear we did something like this where we had... This is a const and so a reference to const initialized with 5. Didn't I have an int pointer though? An int reference pointer xp. Okay, pointers to references don't exist. I will remove that from my memory. It's like if I had a dream about me getting slapped up by somebody and I woke up and the person was like, yo, I did not slap your ass. Okay. Fuck. I am retarded. I believe you. Cool. I have disregarded my belief. Cool. Valid target not found. But if we then include target 3, valid target found. Tank. So we can check. Is there a target or is there not? We don't have to say, instead return no target found, and then it looks like there's actually a valid target. That's pretty cool. Okay. It's convenient and intuitive, that's true. Returning it does come with a few downsides, okay? Yep. Yep, undefined behavior. Well, it said undefined behavior specifically when we dereferenced it. Oh, the point is, yes. Well, it said if we're dereferencing it and it's initialized with how was it? Oh, I guess that's it. Okay, so dereferencing fucks up, but if we do value, then it throws instead, and value or, then it gives the sentinel value, which is not what we want. If you dereference it and it doesn't have a value, we get undefined behavior. Gotcha. If we're dereferencing it literally, not doing dot value. Standard option. The only thing we've done member functions for it would be standard character input, dot clear, dot ignore, dot peek. I think that's it. No way to pass info back about why. We simply are returning null opt, and that's it. Unless it needs to return extra information. I mean, in that case, you could just have... I mean, I guess the point would be that we are saying, hey, yes, asserts exist. But in this case, we don't want to actually kill the program when the user enters the wrong value. We just want to, or when there's not a target found, kill the program by asserting. We instead, because there's gonna be plenty of times where the function's gonna fail. Good. Like, I don't know, you're in fucking Dark Souls and there's no target and you're pressing a button to try and target an enemy. Well, it's saying, hey, there's no valid target. That function that attempted targeting failed. But the fucking program, the damn game doesn't crash. So we need a way of passing that information back to handle it. In this case, we're just checking if it failed or not. If it succeeded or not. If it didn't succeed, okay, we do something else. We just say, hey, no target right now. And then eventually target found. And then boom, there it is. But maybe we need extra information, kind of like an assert, where it says, hey, assert this condition and, or this part of the condition, the important part, and, logical and, we append a C-style string to it to explain why in the terminal. I mean, we could output it before we do a standard optional. We could maybe write it to a file. Don't know how to do that, but we could write it to a file. We could write it to the log by just printing it when we returned it. But maybe there's infinite input, so we just miss it. We could have an out parameter that returns a standard string initialized with the message. So we have a standard string reference, I guess, so we can pass it a standard string for the log, and it's like error log, standard string error log, not const. It's a reference that we pass it as a reference, and then we're returning null opt instead of this value. Well, write the standard string and update the reference, and then return null opt, and then we can check the standard string to see if it failed for this reason. So we check, hey, did it fail? Yes. Compound block, or complex statement, I guess is what it's called, where it's one big block of statements executed itself as one sequential statement, or executed sequentially as one statement. And in there we say, hey, as a condition, if it failed because of this, do this. If it failed because of this, do this. Just like we can say, if not standard character input, meaning that standard character input failed, success failed, I think, is false, then is it because of EOF characters or not? And we can check. So it's like we check a condition and then we do more checks, some nested checks to make sure. But standard null opt doesn't itself return that extra info. It simply returns an empty standard optional or a standard optional with the value that we would expect. How does this stuff cleanly work if I'm actually using those? Meaning, if I have a standard optional with value, can I just initialize it just like normal to another thing? Do I have to dereference it during the initialization, or how does that work? Do I have to treat it like a pointer the whole time? Excuse me. Oops. Okay, and we initialize it with 5. Okay. And now we have int y, and we initialize it with x. Uh-oh. Can't convert from a standard optional. However, I can do x.value, or I could do this x. And really before I do that, if x. Okay, doke, so we do have to treat it kind of like a pointer. So I could do the same thing with a standard string. I just have to assign it the value, not whether it return, not the Boolean part. God, I gotta go to the bathroom again, bro. Holy shit. You're back, sorry. Look at that. Round 3. Holy sauce. All right. Yeah, so it'll return either our cool, or it returns a standard optional, but it's either empty and has no value. Dot value will return false, or evaluating it will implicitly convert to a Boolean, but I can't print it as a Boolean. I can I explicitly cast it to a Boolean? Yeah, sure, we'll leave it in. I was worried because of the conversion, but it's fine. Okay. To a bool. X. It can be casted straight to a bool. Okay. Now let me see what it says. Oh. Forgot that true false is not default. You have to do bool alpha to get that. Cool. Return it instead of a sentinel value for functions that may fail. Okay. That fail, and then we want to do this or this. If we always want to keep retrying, no point in returning a failure value. We may as well just handle it in that function, just like get input. While true, while true, and the only way to get out of it is returning the valid input. And we check if it failed, or if input failed, we remove extraneous input if it failed too, and clear it and whatnot. And then if it didn't fail, we check if there's extraneous input and clear it. And then we return the value, and that's the only way to get out. So if it's asking you for your name, we don't want you to type an invalid character and then it says, oh, it failed, therefore do this instead. Instead, hold on, there's like a little, oh, that's why this is funky. My mouse pad somehow got flipped around. I put it on backwards last time I took it off, which was like 2 days ago when I ordered the new mouse pad to see if it'll fix it. I was wondering, yeah, because there's like a little tiny divot inside the mouse pad. I don't know, I guess something scratched it or hit it or something. And it's been closer to where my mouse usually is. It's closer to me, and I've been hitting it more often, and it's annoying. Cool, alright, fixed. Now it's further away. It's on the other side. Cool. So return a standard optional for functions that may fail, and we want to handle their behavior in a different way than simply redoing them until they're succeeding, until it's successful. Standard expected. Handle the case where it can return an expected or unexpected error code. Yo. An expected or unexpected, meaning like a switch case kind of thing, where it returns these. If it's this error, it returns this, or this, or this, or this, or this, and then returns this. And we could say expected, and then pass in the expected values, and then the unexpected values, something like that. As an optional function parameter, hold. As an optional function parameter. meaning that it's an optional, but it either doesn't have value or it does. Depends on how expensive that is. Because it seems like either you just do a default argument, or, well, seems like this is an alternative to a default argument. Yeah, indeed right here. Boom. Because it evaluates the same way here. We can do it this way. Alright, let's read. Hold. Okay. Pass by address can be used to allow a function to accept an optional argument, meaning that we can either pass null pointer or we can pass in a pointer to something. However, one downside is that a non-null pointer must be an L value. Hold. The non-null pointer must be an L value. Yeah, we can't have a reference of an R value. Okay, instead of a const reference. Alright. But then it must be past something. We can't pass null pointer or nothing. Optional argument is an in parameter. That way we do a standard optional. Oh, could it be a standard optional null pointer? Or a constant? Null. Oh, I guess it wouldn't be null pointer. It would be null opt. Yeah, that makes sense. But the point here is that we would be passing the address to something, versus here, this guy would be directly initialized. Isn't this passed by value versus passing an address by value? So if we're saying this is a pointer to a standard string, then that could be cool. Like a const standard string pointer ID, and your ID is your name, or we say username instead, is null pointer. So if you don't pass in a pointer to a name, then it's null pointer. But if we do standard optional, if I pass in a name, oh shit, hold on. It actually is, well, no, but it holds the value itself though. That's the thing. So I think if we do initialize it, or maybe it is just holding it. So is it holding an address of a temporary, or is it actually holding the value itself? I'm not sure. Because if we check it, cuticle. Okay, so we print ID number with nothing, not known. We change it to 34. Now it is the address of that integer that we can't change. Now it's 34. Or we could do standard optional, and we say that the optional is nothing, it's empty by default, or it's given. So what I could have done before with the standard strings, let's see if I can even find that example. These could have been the problem though is that I would have to be dereferencing them in this example to check them. So this would be a standard optional with this. Can I even do that? Oh shit, I can. Nice. And this has to be dereferenced. Oh fuck, but then I have to check for each one of them. If it's valid, then we're doing it. Yeah, that's not the way here. because I have to check them by default. So I want them to be blank so that I can evaluate each. Because in this case, I have to say if valid, and well, I guess, and if it's not valid, then it'll stop. So maybe that's what we do. So we say if. All right, let's try it. Let's just do standard null opt. And then I just copy this for all of these guys. And then this has to be real. And I can either return a string view for the value of a standard optional, or I can return a standard optional. Okay, and we want to actually include the comma so we know it continues here. Target 4, so this is 1, hold, this is 1, 2, 3, 4. And now here, oh, I think it needs to at least have one valid const expression thing, so maybe that's not gonna work. We'll find out though. And it'll say if target 1 and target 1. So this should cancel the if target 1 isn't valid, and target 1 is valid target name, then return target 1. Or we could just say return target 1. Oh, hold. Okay. Sure. And I'll just copy these real quick. 4, 3, 2. Oops. Else if. Else if. Else if. Else return standard null opt. Okay. I mean, in this case, doesn't really change. It doesn't change. Oh, hold. Oh, well then we're just saying. Oh, when is it when is it doing that? I know, but when is it fucking executing that hold? Let's just abort and find out. Wait, what? What the fuck was it doing? Find this target. These are standard strings. Why are these? I don't know what these are. Why it was skipping to the end there. Checking one, checking this. Oh my! Scared me. Oh, oops. Target 1. If target 2, target 3, and target 4. Yeah, the problem here is we were saying if target 1's valid, but then it's dereferencing target 2. Okay, here we go. Nice. That's the unsafe part. Okay. And then I could just pass it one target and it's not found. But if the valid target was plain, then the valid target is found. Plain. Cool. So in this case, I mean, I wouldn't want to return. The point is that I want to return a value that's either this or this. In these cases, so these are empty parameters that are default, that have default arguments. What's happening can be made static? Yeah. Wait, what? Oh, it has like a fixed thing? Oh, shit. That's cool. I mean, I guess it's a way of me not having to evaluate the actual value of the targets. I can just check to see if they exist first, and only then do I actually look at the value of the standard string. But I don't think the evaluation part is expensive. It's just when we're copying. So seems like if anything, this is creating. I don't know. I don't know if it's actually cheaper or not. I don't know if this is if a standard optional holds an address of I mean, I guess it can't be a temporary. So like, so how is it holding? Is it just a piece of memory where part of it is whether it has value and the rest like one character like or a byte, a boolean, or maybe it's just one bit, and then the rest is all holding whatever value it holds? Seems like this way complicates it honestly and doesn't make it better. But in this case, I could return it either way or do other stuff. Okay. So I could either explicitly initialize it with an integer, or I could leave it as an empty standard optional and then check it. It documents that it's optional. That it's not. Well, I mean, so is a default argument though, so I'm not sure how the optional part is an advantage. And we could pass in an integer. Well, I mean, you could pass in R values too if you just did this, and then. So yeah, if you're doing passing by value, then it makes sense to do standard optional like that. Because if we simply made this a const int ID, the problem though is there's nowhere to check if ID. I'd have to have a specific value that I'm checking, which is the whole point of the optional. So either we could do it pointer way and then compare, but we're doing it all just for a pointer to an integer, all because the pointer allows us to check if the pointer is true or false. So much work instead of just adding some mysterious sentinel value, which in this case is added. It's when the standard optional is implicitly converted to a boolean and returns false. Dot value is false. Excuse me. Okay. Yep. Here's some a little bit about what I was thinking. Because it makes a copy of the argument. That's the problem here. We're not talking about a pointer. We're saying that we're actually copying the value. When it's a string, we might just want to do a pointer to a standard string initialized with no pointer. Yeah, it's exactly what I said earlier, actually. With normal parameters, hold. Yeah, but if we did a const value reference, there's nowhere to check if it's true or false. We lose that sentinel value part. The whole point is because a pointer and a null opt and a standard optional can both be evaluated true or false to see if there's a value or to see if it's evaluatable. Standard optional does not support references. Okay. use const t pointer to evaluate it. So we check, hey, or we're passing in a name, either no name or, yeah, so like, oh, maybe in like different parts of a Silent Hill game or something, where in the beginning you don't know your name and later you do. In the beginning, you get asked a question, there's this function, and it says, hey, what's your name or whatever, and you pass it in, and then it gives you the options, and it's like, hey, you don't know your name, whatever, because default argument for the standard string pointer, or the pointer to a standard string, pointer to a constant. Well, I guess it's not const because it could be, no, maybe not. Oh yeah, because I could pass it as null pointer, I think, right? Can I do that? So we could say include, I need string, I know that for sure. And is this better? Include string, need standard string, int main, return const pointer to a standard string, or a pointer to a const standard string. So const standard string pointer to, pointer to a standard string, and we'll just say a null pointer. Cool. Okay, 100%. So we could do that. Yeah, so I could just pass it null pointer, or I could pass, or just leave it, and then pass it the name at some point, so that at some point it says, hey, you don't know your name. But later, when there is a name and it's valid, it's not null pointer, you do know your name. Cool. And I could do it with standard, or as a pointer. I can't do it as a reference though, because I can't evaluate it. I have to pass it, and it would have to check with the references and say, hey, this isn't the right name. Something. I mean, it'll still work cheaply, but I have to evaluate something extra. But a standard optional doesn't let me do a pointer, so I would actually have to pass the standard string in. Well, I mean, I guess I could call it like this with no argument, but then in the case where it's true, I actually have to pass this guy its value instead of it just being a pointer to it. Because right here, it's passing value. We pass it here. And this is looking at it, but excuse me. I said excuse me when I'm yawning again. I'm so tired. This is passing value here in this case. So we're calling it, we're passing it user ID. 34 is copied to this guy once, and boom. Okay. No references. Yeah. So use standard optional. We're actually passing stuff by value. Gotcha. Yep. Otherwise, use a pointer so we can evaluate it. Okay. Could use standard reference wrapper. Mimic a reference? What the fuck? Okay. A standard string ID. Hey. And a standard reference wrapper. So we have IOStream, optional, and string. We're going to have a function that has standard optional. What the fuck? So we're going to call employee ID with nothing, but then we're going to call employee ID with E. That way we can use standard optional with a reference to a standard string. It's just called E? Why? That's so stupid. Okay, a struct called employee, and it has an ID and it has a name. Print employee ID. And so we use standard optional with the type being a reference wrapper of employee. And the optional is called E. So we're wrapping employee to get a reference to employee. And then null opt. And I guess the get is just reading it. So get dot ID? Okay. Instead of it just being dot get ID. Okay, it's some pointer syntax shit. So we have E, which is an employee, and we are, I guess, pointing to it to do the get. Okay. Getting some sort of thing that it has ID. Okay, we don't know the employee yet. Versus the pointer version where we have IOStream and string, where we can have a struct employee and what a pointer to an employee, and then we can do ID like this. And so we could say, honestly, this seems better. I would fully agree. Yeah. Because we have an employee and it has a name and an ID, and we're looking at the employee to get its name, and we've created it. Created an employee, and by default, whatever, the name is something, but the ID is here. In this case, we're creating employee James and 34. Boom, boom. Printing, and we're passing a reference, or we're passing, sorry, the address of E. And here, it takes a pointer to an employee. Okay? By default, it's null pointer, so no, there's no employee. We can evaluate it. Oh shit, there is an employee. We're not looking at null pointer. Doesn't necessarily mean it's an employee. Well, I guess it must be an employee actually, because this is a type. We don't know if it's valid or not, but well, we do know it's valid because it shouldn't be dangling, and it's not null pointer, so it's gotta be valid. Should be. And we print it, and we go E, and then we point. I guess we get the ID from it instead of doing this reference wrapper stuff. And the whole point of it is what? To use a standard optional. That's one type, and another type is reference wrapper. So I guess reference wrapper is an object that takes an employee, and it allows us to what? Do this get stuff? Is that the whole point? Oh, okay. More of that later. Yeah, I would agree. It doesn't look any better. Really, function overloading is a superior solution. Print ID with nothing versus print ID. Oh! Okay. Set it for 30 minutes. 12. I can't jitter click this angle of the clock. Dude. Time for some fruit. Alright, we'll do in many cases function over. Cool. We'll look at some overloading action instead of optional next time.